So hey there, my name is Prajwal and this video is all about Arduino programming and logic building. So in this video, we are going to talk about Arduino programming, that is the different keywords, functions and constants, variables, stuff that is related with the Arduino programming, as well as we are going to talk about logic building, the basic logic building that is required for using Arduino for particular applications as well as our day-to-day regular programming. So logic building is very important part. And again, after that, we are going to talk about some basic statements and loop functions that are required in almost any programming language. So we are going to talk about all that in this particular video. So we'll begin with it. First of all, I would like to show you the language references which are from the official website of the Arduino. So over here you can see all the functions, then again variables, then constants and structures that are required or let's say supported in the Arduino IDE. So I'm just gonna show you or like brief you about the those which are very important or like very frequent in Arduino programming. So first of all, in the functions, we'll see the digital input output that are digital read, digital write, and pin mode. So again, this is something that we are going to use very frequently. These functions, and again after the analog read and analog write. So it is very important to know what these exactly are. Okay, so digital read and digital analog read are very similar functions. Okay, digital read and analog read, and digital write and analog write. So these are identical statements, but again they are for different purpose. Like it is for digital, and again that is for analog. So digital read is basically used to read a pin, like basically whatever the peripheral that you are connecting to that particular Arduino pin. So it will read the data from that particular peripheral. Let's say I'm using a sensor. So if I'm using an IR sensor, then IR sensor will give out, like for output it will give some data, and that data can be read using this digital read function, right? So the syntax for this function is very easy. Digital read and into bracket, you just have to mention the pin number that your peripheral is connected to, and again the return values are in terms of high or low. So basically high or low is logic 1 or logic 0. So in electronics we deal with 5 volts, and again voltage range from 0 to 2.2 volt approximately is called as 0 or logic 0, and the voltage level that is above 2.5 volt to 5 volt, so the voltage in that particular range is called as logic 1 or high. So this is very important function in terms of reading the senses like for digital. And again analog read is same function, but the thing that is different over here is that the values are not in the form of high or low. The values are in terms of 0 to 1023. So again remember, value 0 is the lowest level and value to 1023 is the highest level. So if you are using a potentiometer or something, so whenever you will shift the value, so the resultant value that is fetched by the Arduino will be something between 0 to 1023. So this is again very important if you are going to deal with potentiometers or let's say sensors that are very sensitive in terms of the readings. So that's it for this and digital read and analog read. So again digital write, and sorry I forgot to mention the syntax for the digital analog read was same just as the digital read. Okay, so analog read into bracket, just mention the pin number, that's it, right? And again, you have to write the semicolons for every statement. It is very important. If you are familiar with the C, you know that semicolon tells the IDE or let's say compiler that my statement is currently stopped. So that is the length of my statement. So it is very important to mention the semicolon after completion of the statement. Okay, so talking about the digital write. So digital write is a function that we use to set a pin high or low. Okay, so syntax is something that you can see over here. Digital write into bracket, just mention the pin number and value. So for this digital write, we are using value as high or low. Again, I explained what is high and low. So suppose I am using an LED. So LED is the output device, right? So I am just going to write digital write into bracket pin number. What you let's say I have connected it to the pin number 3. Okay, so digital write into bracket 3 comma, I'll say high. So whenever I'll execute this command, the LED will glow. And whenever I'll write low instead of high, the LED will turn off. So this is again very simple function used to deal with the digital. Again, analog write is the same function, but the difference over here is that the whatever value that that we are going to write is between 0 to 255, right? So again, it will do the same task just like the digital write, but the difference over here is that the values are going to be between 0 and 255. So this is very important and handy when I'm going to deal with some sensitive data such as the motor, right? So whenever I want to run the motor at a particular speed, I don't know exactly what particular speed, but I am just doing the trial and error. So on that, for that particular task, digital analog write is a very perfect function to use, because I'll just put 100 and check the speed. And again, if I'm not satisfied with that value, then I'm just going to write 125 or 150. So I can experiment with that, right? So it is very important for such kind of sensitive data. And again, after that, these are some math related functions and bits and bytes related, then trigonometry related. So again, these are the functions that we don't generally use. Again, analog reference is a function that by default the analog reference value is about 5 volts for our general 5-volt board such as Arduino Uno. So we don't generally go for changing that value. So I'll not go much deep into that. So again, these are interrupts and stuff. So interrupts is something that we are going to need, but not really right now. So again, serial is something that we are going to need very much in the uh, serial monitor and serial plotter. So it is very important to know what this exactly means. Again, it is very important for connecting Bluetooth modules as well. So the command is serial begin, and into bracket you have to write the baud rate, which is generally 9600. So that depends upon your use. So again, these are something functions that I'll discuss in the further video where I'll explain the serial monitoring. Okay, so now again over here, delay function is very important function, and that is something that we use very frequently in our projects. So delay is something that we use to give a pause before executing the next command. Suppose I want to keep my LED on for 3 seconds. So for that particular task, I can use this delay function. So syntax is very simple. Just write delay into bracket. You have to write the value in the milliseconds. So it is very important. 1000 millisecond means 1 second. So if I want to keep that LED on for 3 seconds, I'll have to write 3000, right? If I want to keep my LED for zero point 0.5 seconds on, so I'll have to write the value 500. So again, this is very important when we are going to deal with some sensitive data, so we can give the delay as per we require. Again, delay in microseconds is something that we don't generally go for, because isn't much precision for the microseconds. So that's it for that function. So now let's take a look at variables. So I just explained what is high and low. These are just the voltage levels. And again, input and output is something that we are going to use very frequent. So in the pin mode, like I forgot, so over here, yeah. So for pin mode, I'll just mention the pin number, and again in the mode I'll write what it exactly is, like if it is an input peripheral or output peripheral, right? It is very important. Suppose I'm connecting an LED to pin number 3. So I have to define what that device or that peripheral is. So LED is basically output device, right? Or we can turn it on or off. So that is an output. I'm not going to read any data from that LED. So I'm just gonna write pin mode into bracket 3 comma output. Or let's say if I'm using an IR sensor, so IR sensor is going to give some data to me, so I'm going to use it as an input, right? So pin mode into bracket whatever the pin that I have connected, let's say 5. Okay, so pin mode into bracket 5 and comma input. So whenever I'll configure that pin number 5 as an input, I can use the digital read or analog read function to read the data from that particular pin. So it is very important to predefine whatever peripherals that you are connected as input or output in the setup loop. So that loop is going to be executed only once and at the very beginning of the program, and after that our loop will be executed where our main program is stored, right? So this is something. And again, input pull up is regarding activating the pull-up resistors. So that is something again we don't generally go for, but if you are going to use that, you can just check out this documentation which is available on the official website of the Arduino. Again, these are the same data types that we generally use in any programming language, let's say C, because the Arduino programming is very much similar to the C programming because of the semicolons and stuff. So array and boolean, byte, character, so double, float. So you might be very familiar with all this kind of stuff, but if you're not, just go take a look at this. Again, like I said, the setup is something that will only executed once, and again, loop is something that will keep executing again and again. Again, these same statements that are in the C language, that is switch case, while, break, else, if. So these are the few statements that currently we are going to take a look at. And again, these are the comparator operators. So these are again same things that are there in the C languages. So I'm not gonna put much stress on this right now. So I'll just shift over this. So I'm going to explain a few statements and loop functions that are very common and very important for Arduino programming as well as our day-to-day life programming. Okay, so if else statement. So what is if else statement is basically I'll give a condition. Okay, I'll just say if this condition is true, execute this execute these statements, and if this condition is not true, execute something else that is written over here. Okay, so let me give an example. I'll just say that I'll just consider a variable. Let's say a, and the value of a is 7. Okay, again let me repeat that. I have considered a variable that is a, and value of that variable is 7. So I'll just write the condition, check if a is greater than 5. Okay, a is greater than 5, and if that is true, I'll write here print high. And in the else statement, that I don't write any condition over here, it will just check if this condition is true or not. So if this condition is true, it will execute whatever that you have written in the statements, that statements you have written in this block. And if that is false, like if this condition is not true, then it will execute whatever the commands that are written in this else section. Okay, so in this else section, I'll write by. Again, let me repeat. I have declared a variable a, and I have assigned the value 7 to that variable, and I have written the condition if into bracket a is greater than 5, print high, and in the else I have written print by. Okay, so now the value of a is 7, and that is greater than 5. So this if condition is satisfied over here, that is this condition is true. So it will not go to the else statement, it will only execute whatever you have written in this if block. So it will print high. Similarly, if I'm going to use a potentiometer, and it is just an example, okay, and if I'm using analog read function, okay, so I want a particular value and I want to turn on an LED after that particular value. Let's say the values are going to be between 0 to 1023. Okay, so I'll just say that I want to turn my LED on only when the value is above 500, and I don't want to turn my LED on until it is above the 500. So for that particular application, I can go for this if else statement. So I can write that if, and again I'll have to use a variable to store the data that is uh, read by the analog read function. So I just consider that var, that is short for variable. So var is greater than 500, and then I'll in the statements I'll just write that digital write, and into bracket I'll just write the pin number of that LED, that is 3 comma high, and in the else statement I'll write pin whatever digital read into bracket 3 comma low. Okay, so this is very easy, and again this statement is not limited for the Arduino programming, it is used in everywhere like C or Python and stuff. So after that we are going to look at for. So this is a loop. So for is something that we are going to use whenever we are dealing with a counting, or let's say incrementing stuff. So like checking. So one by one checking. So for that particular applications, I'm going to use for loop. Okay. So the syntax is very simple. In the bracket, I'll write first initialization, and then condition, whatever the condition that I want to count up to, and again the increment. So for example, I want to print the numbers from 0 to 10. So what I'll do, I'll declare a variable or consider a variable, let's say I, because we generally use I for this kind of purposes. So I'll just write I is equals to 0, then I'll write I is less than 9, or let's say I is less than or equal to 10, right? Less than equal to 10. And I'll give the increment of I plus plus. So I plus plus will increase the value by 1. So if I'm starting with 0, or let's say I'll just write that I is equals to 1 for the beginning, and I is less than or equals to 10, and in the increment I'll write I plus plus. And in the statements I'll write the print whatever the value of I is. Okay, so for the first statement, or let's say first one, it will print the value I, which is 1, and again it will increment that value and check for the condition. Firstly, it will check for the condition that if that value is less than or equal to 10 or not. So if that value is less than or equal to 10, so then it will execute this total block, right? So again, after incrementing the value, it will increment the value by 1. So i's value will be 2. So it will check if 2 is less than or equal to 10, and then print it. Again, it will increment to 3, 4, 5, 6, 7, and it will go to the 10. And after 10, the condition is false, that I is not less than equal to 10. So this loop will break. So no further execution from this loop will be done. Okay. So after that, we'll take a look for, okay, let me give an example for this. So whenever you are going to deal with different types of, let's say, sensors, like if I'm going to use two or more sensors or potentiometers or whatever peripherals that I'm going to deal with. Okay, so I'll have to check for the conditions repeatedly. So I'll have to check that if one of them is on, or one of them is giving high output, or one of them is giving low output. So for that particular task, I'm going to use the for loop. Again, we'll discuss these loops their applications and examples in the further videos. Don't take much stress if you are not getting this right now. After that, we'll take a look at while loop. So while is something that we are going to use whenever you have to count, or let's say repeat a particular set of instructions till the condition is satisfied. Okay, so this is again very similar to the for loop, but again there are some difference in this while loop. So for example, I'll just have to print, again same example, I have to print the values up to 10. Okay, 1 to 10. So what I'll do is that I'll check I is less than 10, or let's say I is less than equal to 10. I'll just write that. Okay, while into bracket I is less than 10. So until and unless the value of I is less than 10, it will keep executing this, whatever the statements that I have written in this while block. It will keep executing them until and unless the condition is true. Once the condition is satisfied, not false exactly, satisfied, like whenever the i's value is reached to less than or equal to 10, it will stop executing it. Okay, so I'll just write the print, and after that print whatever the value of I, and again for the statement 2 I'll write I plus plus. So it will increment the value of I, and when the value of I is less than or equal to 10, it will stop executing it. So by chance, if I skip that condition, like if I skip this I is less than equal to 10, right? So if I start writing odd numbers, so it will go from 5, 7, 9, and 11. So the condition I is less than equal to 10 is skipped. So for that particular scenario, this will keep repeating these statements for infinite time. So you have to be very careful while executing the while statements. Again, this is switch statement. So it is very handy and important whenever you are going to deal with a different number of peripherals, and you have to turn on or off something, or you have to deal with a very particular one. So this is like a choice, right? So whenever I have, let's say I have three LEDs, okay, red, green, and yellow. I have three LEDs, and again I have to turn a particular LED or off between them. So I can use this switch statement. Again, we are going to take a look at examples. So this will give you a clear idea. Okay. So like I said, for the if else statements, this is our Arduino board, And these are the three LEDs that I mentioned. The first one is red LED, green LED, and yellow LED. And the system over here is, let's say, a peripheral, like a potentiometer or a sensor. It can be anything, right? So this system will send some data to the Arduino. Arduino will process that data, and the output is fed to these LEDs. So this is basically our output, this is our processing, and this is our input. So let's say an example, let's take an example of potentiometer, right? Like I mentioned before, that if the value is greater than 500, I want to turn these LEDs on, and if that value is less than 500, I want to keep these LEDs off. So for that particular application, I can use if else statement. Okay, so this is very possible. Or let's say I want to turn the LED on until the value 500 is not crossed. Okay, so as long as value of this potentiometer is less than 500, I want to keep these LEDs on. And once the value is crossed, let's say greater than 500, I want to turn them on. So again, for that particular application, I can go with the while loop, right? So I can just write while, let's say I'll take a variable for storing that data that is received from this potentiometer by using the analog read function, and that data I'll check for the condition. Let's say var var, I'll consider the variable as var, and var is less than 500. So as long as this value is, let's say this condition is satisfied, the LEDs will remain turned on. And once this condition is false, or let's say not true, these LEDs will be turned off. Okay, so that is on you how you want to use them. Again, this is for the loop statements and switch statements. So like I mentioned, for loop. So again, I have considered three particular systems, or let's say peripheral. So if I'm going to assume potentiometer, because we are generalizing every example with the potentiometer. So let's say this is first potentiometer, second potentiometer, and third potentiometer, right? So again, there are three LEDs, same LEDs. So what I'll do different in this example is that I want to turn on the LEDs only when two of these, let's say, potentiometers are above 500. So if the reading from two potentiometers, any two potentiometers is above 500, only then the LEDs will glow, right? So I'll keep shifting, changing the values of these potentiometers, and Arduino has to analyze the values that are it is obtaining from the peripherals, like these three systems, like three potentiometers, and turn the LEDs on or off. So for that particular application, I can go with the for loop, or let's say, let me take another example. Depending on these three systems, or let's say, I'll just take them as buttons. Okay, so these are the buttons. Let's say they are not potentiometer right now. These are buttons. Okay, and when I'll press the first button, I want to turn the red LED on. When I'll press the second button, I want to turn the green LED on. When I'll press the third button, I want to turn the yellow LED on. Okay, so for this particular application, I can go with the switch statement. Again, how and why we can discuss in the further upcoming videos, but this was just something general to give you an idea about what and exactly how we are going to do. Okay, so key points of this entire video are the very important functions that are we are frequently using in the Arduino programming are digital read, digital write, analog write, pin mode. Again, the variables that are high, low, input, output. Again, the delay function. So these are something that we are going to require a lot of time writing any program. And again, after as you go deeper and deeper, like when you are going to design a complex project, or let's say off the track project. So for that particular applications, you are going to read other functions as well, like for the math operations or bits and bytes related operations. So you are going to need all those functions later, but that is not something that we are concerned with right now. So for this particular session, just be concerned over these loop statements, or let's say statements, and again the examples that I have told you. So these are something that we are going to deal with right now. And again, I'm going to show you an example of the potentiometer using if-else statement. So just take a look at that. So that's it for the today's session. And again, we are going to discuss all these things in detail in upcoming videos. And if you haven't still checked my other videos yet, go watch them right now. And thanks for watching.